Welcome to Maths for All. I'm Aisling Flynn. This is exam practice. And this is an exam question from section B of a paper worth 50 marks on sequences and series or number patterns. So, the first three patterns in a sequence of patterns of tiles are shown in the diagram below. So we have pattern 1, pattern 2 and pattern 3. Draw the next pattern of tiles onto the diagram above. So first thing we'll do is we'll study what we have. So we seem to have this shape that goes up and over and down, okay? And let's see what's different each time. So here you can see that we have 3 across and we have 2 down. Okay, the second pattern we have 4 across and 3 down. And the third pattern we have 5 boxes across and 4 down. Okay, so with each successive pattern we are gaining one box sideways or horizontally. So in pattern 4 we will have 6 across. So 1, 2, 3, 4, 5, and we'll put on another one, 6. Okay, so 6 across, and we're also gaining one to the end of each arm. It's getting one bit longer, or arm or leg, whatever you want to call it. So we should go down by 5. Okay, so the top one is 1, we have 2, 3, 4, and we'll have a 5th one. Okay, and it will be the same over here. Now, so that is our pattern 4. Okay, let's look to the next slide, or to our, and here we have our marking scheme. So this is pattern 4, and let's count. Do we have 6 across? Yes, and 5 down. Okay, on both sides, and we got it right, so we're going to get 5 marks for that. Okay, part B says, based on the pattern shown, complete the table below. So I'm just going to add in the patterns, the 3 that were given initially and our answer for pattern 4. And we have to complete this table. So we have the pattern number n, which is 1, 2, 3, 4, 5, and we have number of tiles. So they've done the first one for us. They've counted 1, 2, 3, 4, 5. Okay, and we just have to fill in. For pattern 2, we have 1, 2, 3, 4, 5, 6, 7, 8. So we'll fill that in there. Pattern 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and you are seeing patterns emerging. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 for pattern 4. Okay, so let's recall from the first part, each time we drew a new pattern it got one box wider, but we added 1 in length to both of these legs or arms, whatever you want to call them. So in total we're adding 3 extra each step. Okay, and you can see that with the pattern, the number pattern here. 5 to 8 is plus 3, 8 to 11 is plus 3, 11 to 14 plus 3, and so we'll add another 3 to get the 5th one, which we haven't drawn, and that is 17. Okay, so that's the table complete. Let's check the answer, and we got it correct. Oh, the 5th one is missing there. Okay, got it correct. So to complete the table fully correct you get 5 marks, but there is opportunity to gain partial credit. So you'll get 2 out of 5 if you got 1 or 2 correct entries, and 3 out of 5 if you got 3 correct entries. Okay, and 5 out of 5 for all correct. So part C. Part 1. Assuming the pattern continues, the number of tiles in the nth pattern of the sequence is given by the formula Tn equals Pn plus Q, where P and Q are natural numbers find the value of P and the value of Q. Alright, so this is a roundabout way of asking about the general term Tn. Okay, it's an expression in algebra that allows you to calculate any pattern down the line of the sequence. Okay, the P and the Q tend to confuse things a little bit. Okay, but what do you know about Tn? We're going to find the general term Tn first, and then we'll compare it and we'll see, can we see what is the value of P and what is the value of Q. So we're looking for the general term Tn. Now, you have a little bit of help in your formula and tables books. We have an arithmetic sequence in this question because we're adding 3 each time D is constant. There is a constant difference. Okay, so make sure you're looking at the correct type of sequence, and we're looking for the general term. So Tn is the nth term, and we're going to use this Tn formula. Okay, so we'll start by writing that down. Alright, so Tn equals A plus n minus 1 times D. Okay, so what is A and what is D? A was the first term in the sequence. So if you think back, the very first term was 3 across with length of 2 down, and when you counted them you got 1, 2, 3, 4, 5. So A is 5, and as we discussed, they're increasing by 3 each time, so D is plus 3. So we're going to fill the values we have into our Tn formula. Okay, so we'll put in 5 for A plus n minus 1 times, multiply that by 3. Okay, let's multiply and simplify. So 5 plus 3 times n is 3n, and minus 1 by 3 is minus 3. And then we'll simplify by putting the numbers together. We have 5 minus 3 plus 3n. So we'll have 2 plus 3n. Or, if you want, you can reorder. You get 3n plus 2. Okay, so there's my general term, but that's not what we were asked. We were asked to find the value of P and Q. So if we write directly underneath that, Pn plus Q, simply by comparison, what do you see beside the n term? We can say that P is equal to 3, so direct comparison. And what is the number part or the constant part? We can say that Q is equal to 2. Okay, so let's check our marking scheme. Alright, so we got our Tn correct. Alright, we got P is 3 and Q is 2, and there were 10 marks going for that, but you do get opportunities to gain partial credits. You'll get 4 out of 10 if the Tn formula is written down with some substitution. So always write your formula and then attempt to put in some numbers. Okay, or if you write down the values of A and D, you'll get 4 out of 10. High partial credit, which is 6 out of 10, if you fully substitute numbers into the Tn formula. Okay, or if you get one of P or Q but not both. Okay. Alright, so there we go. The next part. How many tiles are in the 20th pattern? So 20th pattern, how many tiles? We're looking for T20. Now, we've done some work just previously that gave me the nth pattern was 3n plus 2. So use that going forward. Okay, T20 will be equal to, so replacing n with 20, and 320s are 60. So T20 is equal to 62. There are 62 tiles in the 20th pattern. Let's check our answer. Correct. 5 marks for that, 2 for partial credit if you write the formula with some substitution. Okay, if you start listing the terms but don't get T20 correct, you may get some marks also. And part 3 of that asks, Find which pattern has exactly 290 tiles. So T something, so Tn is 290 tiles. Okay, so this question asks you to find n. So which pattern? So what place in the sequence is it? What is n? Okay, so we're going to use what we've generated before, 3n plus 2, and we're going to put 3n plus 2 equal to 290, and we're going to solve this simple linear equation. Okay, so what we'll do is we'll take 2 from both sides initially to get rid of that. So we'll have 3n on the left equals 288 on the right, and to find the value of n we'll divide both sides by 3, and so we'll get 1n equals 2, and 3 into that goes 96 times. So the 96th term has 290 tiles, and we got 96. Excellent. And there's 5 marks going for that. Partial credit of 2. If look at this is interesting. If you got the correct answer without work, you only get 2 out of 5, so please present all your work. If you wrote down the formula, you got 2 out of 5. Okay, so always write down the formula if you don't know anything else. Okay, so there's a part D to this question also. Let's have a read. Show that Sn equals 3n squared plus 7n over 2 is a formula for the total number of tiles needed to build the first n pattern. So we're looking for a formula. We're looking for the total number of tiles. So that's when you keep building the tiles, but you add up the individual numbers from each part of the sequence all along. So it's called sum, and the letter S is used. So you keep building patterns, but you don't take the tiles away, and you're adding up. So if you recall, our first term was 5, the next one was 8, the next one's 11. So you're going to be adding up. S3 would be equal to 5 plus 8 plus 11, for example. Okay, but we usually use a formula. So when in patterns, all right, you see the word total, it means sum. Okay. Again, we have some help here in our formula and tables book. Again, make sure you're looking for at arithmetic sequences. We're looking for Sn, or the sum of the first n terms, and we have this formula here. So these are all on page 22 of your formula and tables book. And this is what we're going to use here. So we'll write down that formula, and that's what we'll start with. So it's n over 2 times 2a plus n minus 1 times d. Okay, and we have to work with that and eventually come up with this that we're given in the question, because we're asked to show. Alright, now notice that no a or d appears in the final product, and that's because we know the values of a from before. A was 5 and d was 3. So we're going to start by substituting in for those. Alright, so we'll have 2 times 5 plus n minus 1, and that's to be multiplied by 3. Okay, so you've seen in previous examples you may get some marks for writing down the formula. You may get more marks for substituting the right numbers in the right places, so always give it a go. And after that we'll just work some things out and we'll hope for the best. So 2 5s are 10, plus n times 3 is 3n, minus 1 times 3 is minus 3. So we'll go again. Let's work out what's inside that bracket. Okay, so we have an n term. I'm going to write that there. And then what do we have in terms of numbers? We have a 10 and a minus 3. So 10 minus 3 gives me plus 7. So glance one more time up at what we have to end up at, and I think we see where it comes from. We're going to multiply along the top line by that n, and everything will be divided by 2. So along the top line we'll have n times 3n, which is 3n squared. We'll have n times the 7, which is 7n, and everything should be divided by the 2 that's underneath, and that's what we were asked for to show. Okay, so there you have that. Let's look at the marking scheme for that part. Alright, did we get it right? Yes, we did, and there were 15 marks going for that. Again, opportunities to get partial credits. So if you did the correct formula with some correct substitution, you're going to get 6 out of 15, or if you wrote down your values of A or D, you'll get something. Okay, and if you fully substitute into the formula, you're going to get 10 out of 15. Okay, so formula, substitute, and then work it out and hope for the best. So part 2 of that section, find the total number of tiles needed to build the first 30 patterns. So there's that keyword total, to build the first 30 patterns. So what we're looking for here is a sum. So when you see the word total, sum, and we're looking for S30. Now from the previous part we have Sn equals to 3n squared plus 7n over 2. So if we want to find S30, we can use that. Okay, so we'll do 3 times 30 squared, okay, plus 7 times 30 is going to be a large number, all to be divided by 2. So here's where you get your calculator out. Okay, and you can take as many or as little steps to get to the answer as you require. Okay, and I get a sum of 1,455 tiles. Alright, so let's check our answer. So did we get it correct? Yes, we did. There were 5 marks going for that, and again, as always, opportunities to get some partial credits. For example, if you write down your values of A and D, you're going to get 2 out of 5. Okay, high partial credit, 3 out of 5 if you substitute correctly into the SN formula. Okay, so always give it a go, write down a formula, put the correct numbers in the correct places, and hopefully you'll get most marks. So that was that question.